This video, we're going to talk about repeating code using what are known as loops. Loops are a way, in fact, we have about two different types of loops that we're going to learn here. One is called a while loop and one is called a for loop. Now we choose one based on the other based on what we want to do with it. However, we could use both loops or either loop. It's just that one is clearer in its intent based on what it's going to be doing. So for example, we have what is known as a while loop and a for loop. So a while loop is generally good for anything that has an indefinite condition. So for example, if we wanted to keep asking the user for a yes or no question, do you want to keep executing this code? And they keep typing Y. Well, that's indefinite because you and I right now, we can't count how many times that code is going to execute. There is no set number of executions or what are known as iterations, which is the execution of a loop. There are no known iterations of that yet. So we would use what's called a while loop. A while loop says, as long as this condition is true, execute the code. Now in the lecture notes down about right here, you could see an example of a while loop diagrammed. So in the while loop, we have this blue repeat, and everything that belongs inside the while loop here, like where it says iteration, will keep executing over and over again as long as the condition. Now the condition in this case is A is not equal to B. We don't know what A and B are right now, but this is just an example. So let's go ahead and put something inside there. So what I've done here is I said while A is not equal to B. So what I'm going to do is I'm going to grab A from the user. Now I could convert these to integers, but remember, all we're doing right now is just considering that A is not equal to B. So it doesn't really matter what data types they are, because remember, we can compare strings just like what we can compare integers. So down here, I'm just going to print end program, just so we know when the actual loop quits. Now, the thing about this is let's take a look at this. I'm going to enter A and B right here. However, what's the issue with this? Now, the issue is that A and B are undefined. So if I try to run this right now, it says name A is not defined. So remember, a Python program starts from the top, works its way to the bottom. So this A right here is undefined, this B is undefined. So there's many different ways we can do this. So the condition is checked first. So what we have to do is we have to sort of get the condition checked to pass before we can go any farther. So there's two ways we can do it. Number one, we can create what's called an infinite loop. And then we control the condition by using an if statement, because there's another statement called break. If I put break inside of a loop, it will immediately break out of the loop and the loop is done. So we can conditionally execute a break using an if statement. So it's sort of like the condition here. So it's sort of, if I wanted to use a break, what I'd have to do is we'd have to have a condition that's always true. Now, remember, all conditions, double equal sign, not equal, that sort of stuff, will boil down into a bool, which is either true or false. So while true in this case will always execute. There's no way it'll terminate unless we break out of it. So then what I can do is I can grab A and B and then say if A equals B, break. Because remember, we wanted to keep executing the loop as long as A is not equal to B. Well, what's the opposite of A not equal to B? Well, it's equal to B. So the opposite of something not being equal to it is being equal to it. So in this case, what's going to happen is if A and B are equal to each other, we break out of the loop. And because the break statement's here, we're going to skip print iteration. So let's go ahead and do this and we'll see what happens. Excuse me. So notice that the error is gone. Name A is not defined. So I use this construct a lot. However, a lot of students, a lot of people don't really like it. In C++ and other high-level languages, we have what's called a do-while loop, where the condition is checked after the loop body is executed. Unfortunately, we don't have anything like that inside of Python, so we sort of have to do something like this, where we execute code, then check a condition using an if statement like we did on lines 5 and 6. So now I'm going to enter A as 5 and B as 10. So obviously, these are not equal to each other, and so we're going to fail, so that if A equals B is going to evaluate to false. Now remember, in an if statement, if we evaluate to false, we skip it and run the next line. So notice it says iteration. Then we go 5, 6, sorry, that's 5, 6. Remember, it's a string, 51. Iteration, as long as they're not equal to each other, 1, 2, 1, 2, 1, 2. And notice it's executing code as long as A is not equal to B. Why? Because we are controlling that with that break statement. But as soon as I do 1 and 1, it ends the program. Why? Well, here is where the actual check is done. This break statement is what breaks us out of the while statement. Now, one thing to check here is notice that we say enter A, enter B. Whenever we break, notice the iteration did not get printed. Even though it's the very next line, break will immediately break us out of the while loop, skipping any additional code inside the while loop. And then we break out down here. So recall that a while loop is like this. We have an indefinite number of iterations. As long as A is not equal to B, we're going to execute an iteration. So this is a way where we can have an indefinite iteration. So let's take a look at the second type of loop, which is called a for loop. So a while loop, once again, is you have an indefinite condition. You want to keep executing loops until something occurs. A for loop means that we can count it. Now we can say x equals int, enter a number of iterations. And so what the user is going to do now is enter the number of iterations, and we're going to count this number of times. So Python knows that this is a very common way to use Python. So we say for I in range x. So range is actually given to us. Python has a built-in function called range. And what that's going to do is say x is 5. That's going to generate a range of 0, 1, 2, 3, and 4. That's 5 total values. So one thing that's important with range is there's actually 3 different ways we can use range. And I'll show you what those look like here in a little while. So for I in range, I'm just going to print I. So remember, range is going to generate 0, 1, 2, 3, and 4. Well, in this case, it says, okay, for I that's inside of this range. So for the first iteration, it's going to be 0. Second iteration is going to be 1. And it's going to go in ascending order like that because range is in ascending order. So let's come down here and say end program, just so that we know when it ends. So what we should see is we should see numbers printed because range will generate a range of numbers. So in this case, let's just say we want 5 different iterations. Okay, notice we get 0, 1, 2, 3, and 4. Well, that's because range of x will generate 0, 1, 2, 3, 4. So it starts with 0 if I do this, but notice that 5 is not included. It gives us 5 total numbers. It starts with 0, ends with 4. So that's the second range that we're going to say. So range can have 3 different ways. So we can do range of x, and that's going to generate 0 up to, but not including x. So it looks something like that. Range x and y. So let's actually make it backwards so that we have some consistency here. So range of y and x is going to start with y inclusively, and it's going to end in x exclusively. And then finally, we have range y, x, and then what's called the step. And for each iteration, it's going to start at y and end at x. However, it's going to step. So whereas the lines 4 and 5 will add 1 to the iterators. So in this case, 0 goes to 1, 1 goes to 2, 2 goes to 3. Line 6 allows us to put a step in there. So if we want to multiply by 2, if we want to add 10 to each one. So let's see what that's going to look like. Let's go from 0 to x, and let's step 10. Okay, so now what I'm going to do is I'm going to do a 100. So number of iterations, we want 100. And notice what happens. So we start at 0, and it goes to 10. Well, why? So x is going to be 100. So that's our stopping point. And notice it actually does not print out 100. That would be the next 10 because the end of a range is always exclusive. The start of a range is always inclusive. Notice that 0 got printed. So this 10 tells us that after you're done, where it says I in range, it's going to get the value x or whatever I is plus 10. So the very first iteration of I is 0. Plus 10 is 10, plus 10 is 20, and so on and so forth, up to but not including x. So those are the 3 different ways we can use range. So as you can see, for loops do something like this. Now, we generally are going to use range a lot for this case. However, we can iterate over different types of elements. So for example, if I had a list just with random numbers that I'm popping in there, we can say for I in x. So what that's saying is for each one of the elements inside the list called x, I want you to print out I. And you can see we get 1, 2, 3, 7, 9, 4, 2, 1, 2, 3, 4, 5. So it prints out everything inside of there. And I is just a plain integer. So we can do I raised to the second power, or we can do 2 to the I power, or something like that. So since I is just a plain old integer, we can do whatever we want to it. So 2 raised to the first power is 2. 2 raised to the second power is 4, and so on and so forth. 2 raised to the 7th power is 128. To the 9th power is 512. So as you can see, I is just being treated as a normal integer. In fact, we can convert it into a float if we wanted to by saying float I. And so that is because it's getting the value of X. Now look what happens, because remember, in a list, we can have heterogeneous. So I'm going to create our heterogeneous elements inside of a list. So I'm going to create H. So what's going to happen is on the first iteration, I is going to be 1. On the second iteration, I is going to be the string H. And notice what happens. It prints out the 2, so that was fine because I is an integer. However, when it got to the H, it tried to raise 2 to the string H power, and it's like, hey, I have no idea how to do that. One's an int and one's a string. How do you want me to do that? So essentially what I'm saying is for I and X, you don't know the position that it's actually in. So there's another way we can do this. So if you're just going to print or say we wanted the sum of all of these elements, we can do sum equals 0, sum plus equals I. And then what we do is we say print sum of the list is equal to sum. Okay, sum of the list is equal to 40, and that's all these numbers added together. So as you can see, we could treat I in there. However, say what we wanted to do is add 10 to each and store it back in the list. Okay, so I can't do I plus equals 10. So let's take a look at X. So I did I plus equals 10, so this should go from 1 to 11, but it didn't. So this is just a copy of the element inside of X. So you have to be careful about that whenever you want to do that. So what we can do is we can sort of use that range operation, and we can get the length of a list by using len. So what we're going to do is we're going to iterate I through a range of the length of X. So now the length of X in this case is 3, 6, 9, 10, 11. So there's 11 elements in there. Len of X will give us 11. So it's going to give us, whenever we pipe that into range, it's going to give us 0 through 10. Wow, that's interesting, because on a list always starts with 0 and always ends with length minus 1. Perfect for the range function in this case. So now what I'm going to do is, remember, we can index into a list by using the subscript operator, which is these square brackets. And I'm going to say that is equal to xi plus 10. Now, if you didn't know, xi plus equals is shorthand for line 5. So line 6 and line 5 will do the exact same thing. It's just shorthand for it. And I like the shorthand just because it's easier to see. Then what we're going to do is print out the list and see what happens. So notice in the list, we've actually updated each one of the elements inside of the list. So what I'm going to do here is I'm going to print the length of X. So as you can see here, oops, that's not what I want to do. There we go. So now when I print the length of the X, we get 11 here. So there's 11 elements inside there. And what we've done is we've actually updated those by adding 10 to each one of them. So that's something that we can do inside of a list. Now, remember, in a dictionary, we can iterate through the keys. Let's create a dictionary here. Let's say A is equal to 10, B is equal to 20, and C is equal to 30. So remember the two different ways we can go through a dictionary. We can go by the keys, or we can go by the value. So in this case, whoops, I forgot the colon. There we go. So in this case, we see ABC. Those are the keys that we want to print out because I is going to get the value of the keys. Or we can go values. And notice we get 10, 20, and 30. So this for loop is used for essentially two different things. If we know how many we want to count, now what we can do is we can ask the user, how many do you want to count? But as long as the item is countable, then generally we would use a for loop. Or if we want to iterate through a dictionary, a list, or some sort of sequence, then we would use a for loop. If it's an indefinite condition where we're waiting for something to occur, then we would use a while loop. So let's take a look at why we would do something like this. So say we wanted to build a calculator where the user is going to input a series of operands and operations. So what we're going to do is, in this case, we're going to say while true. So once again, this is going to happen a lot whenever you're expecting input from the user. You use while true a lot because you don't know what the condition is going to be until you get the input from the user. So you don't know if the condition is going to evaluate to true or false until we get input from the user. And for each iteration of the while loop, we're going to get input from the user. So the first thing we're going to do is going to get the left operand. Then we're going to get the right operand. And then we're going to get the operation. Okay, so now we have left, right, op. So if the op is Q, what we're going to do is quit. So we're going to say if op is equal to Q, then we're going to quit, which is a break statement. Okay, so this, if you don't remember if statements, that was the last video where we did conditionals. Now we're still using conditionals because remember, inside the while loop, the condition goes here. I'm just sort of short-circuiting it by saying while true. So that way there, the condition never evaluates to false. Remember, in a while loop, if the condition is true, we keep executing the loop until we either hit a break statement or until that condition becomes false. Well, since we hard-coded true in there, it's impossible for it to become false. So the only way to stop a while loop that has a while true is to use the break statement, which we're doing here. If the op is equal to Q, then we break. Otherwise, if the op is, let's say, X, we're going to multiply and print out left times right. Otherwise, we need two equal signs. Otherwise, if it's plus, we're going to print left plus right. Otherwise, if the op is minus. Okay, and then finally, else means it was none of the above, and we're just going to say invalid operation. Okay, so in this case, you can see we have an indefinite number of iterations. We're going to keep asking the user for calculations until they type Q for their operation. So I have an equal sign in there. I don't know why I'm doing that all of a sudden. There we go. So enter the left operand. We're going to do 10, we're going to do 20, and we're going to add those two numbers together. Notice it prints out 30, which is correct. And then the while loop goes right back to the start and inputs the left operand. Let's do 10, 20, multiplication, X. Okay, so that's 200. That's exactly what we expected to be. Now let's try 10, 20, and a Q to see what happens there. Notice it quits. Okay, let's run this again, and let's run the invalid operation. Let's go U, invalid operation. Okay, so let's go 10, 20, Q to quit, and there you go. So this is essentially what a while loop is good for, is to do some sort of operation like this. Now, if we're going to do something like error check input. So for example, if you're going to error check input, as long as it's a Q, X plus or minus, notice that the op can change. So what we're going to do is we are going to use what's called a nested while loop. So we're going to say while op not in Q, X plus or minus. And I'll show you a better way to do this, but we're right now just going to do it this way. So that's not what I want to do. Okay, so now I'm going to take out this else statement because it has to be one of those, because we have Q, we have X plus and minus. So while this is not correct, we're going to print out invalid operation, and we're going to input a new operation. So you can see we're going to overwrite operation until the op is either Q, X plus or minus. So we run this. Now we don't say invalid operation. We're actually going to get an operation, because remember, if we had an invalid operation like we did up here, we went all the way back to enter left, enter right, and then enter operation. Well, no, we want to just ask for the operation. So I'm going to do 10, 20, U. Notice it says invalid operation, but it doesn't go back up to the top. Instead, now it's going to say enter operation, Z, 1, 2, 3. Okay, then let's add the plus, and notice it breaks out of the loop because op is now inside of there. So the plus operation is right here. So doing things on a sequence like this is very important to see how this is going to work. So let's make sure we got all of it. So you've seen while loops, you've seen for loops in the old style, or in the types and conditions, in just conditions. There we go. In the conditions, you saw that we can use and or for the conditions. And the same thing happens here. So we can say while true and true, or false, or something like that. And we can add conditions inside of them. Remember, for an and condition, all of the conditions have to be true for the entire thing to be true. So if you remember, I wrote this under conditions, but let's say we had and. We have the left operand, we have the right operand, and then we have the final result. We'll call it condition C. There we go. So if the less is false, 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 true, true, false, true, true. So on an and, if the left and right are both false, the end result is going to be false. If the left is a false and the right is a true, we still have a false, false, and true. So hopefully you remember that from the conditions lecture, in which the only way we can get it true is if both elements are true, or if both conditions are true. An or is a little bit different in that if we have left, right, in the condition, if we have false, 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 true, true, false, true, true. So in this case, if we have a false and false, obviously nothing is true, so we're going to get a false. In this case, one of them is true, so that means or this one is true. We're going to get a true, and a true. So you can see the differences between and or, and that works for the same condition for a while loop as well. So a while loop, this condition right here inside of a while loop is exactly the same as a condition inside of an if or an else statement. So let's clear that. So that's the important thing to note in there, is we can actually combine condition using ands. Now remember, in a while loop, these ands and ors, even with an if statement, the ands and ors will eventually boil down to one, either true or false, based on that truth table that we saw. So in a while loop, we do not execute the body of a while loop. In fact, we skip it all if the resulting condition is false. The only way we execute the internals of a while loop is if that condition evaluates to true. Now, remember what I've done here is I've sort of made an indefinite loop, an infinite loop, by saying while true. And the reason we've done that is because our break statement is now what's going to control when we exit this while loop. Now, once again, remember that the break statement exits us completely out of the while loop and skips all code that's beneath it. So let's go back here and be able to repeatedly execute a block in code until a certain condition is met. So if we're going to do that until a certain condition is met, we're going to use a while loop, not a for loop. Be able to prematurely break from loop using the break keyword. I showed you that using an if statement. Understand what constitutes as an infinite loop. That means a loop that does not ever break on its own based on the condition. So if you don't have a break keyword and you have a while true, that's an infinite loop, and it'll probably just drain the resources of your computer. Be able to prematurely execute the next iteration of loop using continue. So that's the one I did not show you. So let's do this real quick. The continue is sort of like break, except what it's going to do is it's going to continue to the next iteration. So let's do this for I in range 100. So whenever I run this, notice we get 0 through 99. Well, let's say we only wanted to print the odd numbers in there. So if it's even, we don't want to print it. We just want to move on to the next iteration. So we say if I mod 2 is 0. So remember, the mod operation, which is this percent sign, is the result after division, or it's the remainder after division, not the quotient. So the quotient is the front slash, the remainder is the percent sign. So remember, if it's even, it's evenly divisible by 2. That's what an even number is. So if this is an even number, we're going to continue. We're going to skip over it and go to the next iteration. So now notice that we only have odd numbers being printed. Why? Because this continue keyword will skip anything underneath it, almost like the break keyword. Now remember, break is going to break us out. So let's take a look at this real quick. So this continue keyword stops here and then moves right back up and grabs the next range. Whereas a break keyword will break us out of the loop and bring us down to the next line underneath the loop itself. So that's the difference between a continue and a break. Understand and be able to differentiate the terms iterator and iteration. So remember, iterator is sort of a number that's keeping track of what iteration we're on. An iteration is just a sequence. It's just a one execution of a body of a loop. So if the loop body, like in this case that we saw, for I in range 100, we know that's going to go from 0 to 99. So in this case, I is the iterator. It's what's keeping up with what iteration we're on. However, it's going to iterate 100 times. The first iteration is where I is 0. The second iteration is where I is 1, and so on and so forth. So that's the terms iterator, iteration, and so on and so forth. So an iterator, once again, is this number that keeps track of what iteration you're on. And we know based on how many times this loop is going to execute, that's the number of iterations we have. That's why a for loop, essentially, if we know the number of iterations, we'll use a for loop. If we don't know, if it's an indefinite condition, we will use a while loop. So that's essentially loops in a nutshell. It's very straightforward if you actually wrap your head around the concepts. The syntax is usually what gets in the way, because a for loop looks like it has a lot to it, but it really doesn't. You'll essentially be using for loops to look inside of lists, dictionaries, and a count. So if you ever need a count or something like that, that's what you're going to use a for loop. And as you saw, whenever we presented a menu and we're getting user input until they quit, we use the while loop because that is an indefinite condition. There you have it. That is loops. Thanks for watching.